All right, let's look at this carbon dating problem. All right, so it says this carbon-14 has a half-life of 5,715 years. All right, then so ancient charcoal contains only 16% of the original amount, and we want to know how old this piece of charcoal is. All right, so let's do that. All right, so since the carbon-14 decays exponentially, so we can have this function. So amount of carbon-14 after t year is C of t is equal to initial amount. I'm going to just call it C0. We're not going to really need it. C0. Then exponential function e to the kt. Right? We don't know k yet, but we can figure it out. All right. Then also it says that it's a half-life. So half-life is listed here. So half-life is 5,715 years. So half-life. All right. So how do we use this? 5,715 years. All right. So let's try to use this. All right. So this means what? So this means that if you plug in t equals 5,715, you're going to get the half of the original amount. Original amount is C of 0, C sub 0. So it's a half of that, right? So, but the first I'm going to plug it into the formula. So you have a C0 e to the k times. So t is 5,715, right? And this is supposed to be equal to 1/2 of C0, right? So let's try to solve for, you can actually solve all the way to k, but I'm too lazy to do that. I'm going to actually solve for e to the k as a chunk. So I'm solving for e to the k, right? All right, so first thing we would do is, since the C0 is in common in both sides, we can actually divide through by C0. We can get e to the k, right? And we still have to raise it to 5,715. And this is going to be equal to just 1/2, right? Because C0 is canceled out. All right, then we need to get rid of 5,715 so that we can isolate e to the k. So all you have to do is just erase both sides of the equation to 1 over 5,715th power. All right, so that way this is canceled out. So you have e to the k all by itself. So you have 1/2 raise it to the 1 over 5,715. All right, so once you've done that, we can plug this guy right here. So what we found here, right back into, I'm going to go through here. Here, this is a e to the k, e to the k right there. All right, so we know that the formula, we know a little bit more, is equal to C0, right? So e to the k is 1/2 raise it to the 1 over 5,715, and you have a times t, so it's going to be t over 5,715. All right, so we have this formula. All right, Then using the fact that this charcoal has only 16% of the original amount, so what we can do is we can set this guy equal to, so we're going to set C of t equal to 16%, so it's going to be a 0.16 or 16 over 100 times the original amount, which is C0, right? Then we just have to solve for t. So this is going to be, right, again, first thing is C0 is on both sides, so we can just divide through by C0. So we have 1/2 raised to t over 5,715, and this is equal to 0.16, right? Then we want to isolate t, so what we can do is we can apply natural log to both sides. So we have a natural log of 1/2 raised to the t over 5,715 is equal to natural log of 0.16, right? Then what we can do is we can use the log property to bring this power in front of the log, right? So this is going to be, we have t over 5,715 times natural log of 1/2 is equal to natural log of 0.16. All right, since we're interested in finding the value of t, we just need to get rid of 5,715 on the bottom and a natural log of 1/2 on top. So what we can do is we can multiply by 5,715 and divide by natural log, sorry, it's kind of small, natural log of 1/2, right? So that way t is all by itself, right? So you have a natural log of 0.16 was already there, and you're multiplying by 5,715. Then we want to divide by natural log of 1/2. I'm going to put the 0.5 so it's easier to punch it into a calculator. All right, so let's find this value here. All right, so I'm going to bring out a calculator. All right, so we need to find a natural log. So let's see. You have a natural log of 0.16, right? Then multiply by 5,715, divide by natural log of 0.5, right? So we have that and punch into a calculator. So it came out to be 15,109.6. Right, so since the answer wanted to be one decimal place, so this is it's going to be 15,109.6. Unit is years. All right, so let's type it in. All right, so I'm going to just open this up. So we found that to be 15,109.6. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.